Hello everyone. So welcome all for a lecture series in our design of mechanical system. Today we'll discuss about the first module, that is a methodology, morphology, optimum design and design of system with respect to mechanical system design. Okay, in previous lecture we have seen the basic process of mechanical system design. Now today we will discuss about the different type of designs and the basic methodology of design of mechanical system. So in the types of the design, it can be classified in many ways. Okay, is based on the knowledge, skill and creativity. Based on that, the design process can be done. Okay, so generally design is classified into three types. First is a adaptive design, second one is a variant design, and third one is a original design. So what is the adaptive design? In the most design situation, the designer's job is to make a slight modification of the existing design. These are called as a adaptive design. This type of design needs no special knowledge or any extra skill, that is a converting mechanical watches into new shape. Okay, this is a simple example of adaptive design where we are doing only modification rather than a new innovative design. Another simple example, in a market we look specs, or you can say a simple pen. The basic function of the pen is, the purpose is to write whatever we will. Okay, but the design of the pen is an innovation thing. But whenever we change the shape and size of that pen, it is not a innovative. It is a nothing. It is nothing but it's a modification in design. Okay, that could be we are considering in adaptive type of design. Next one is a variant design. This type of design demands considerable scientific training and design ability in order to modify the existing design into new idea by adapting a new material or different method of manufacturing. In this case, the designer starts from the existing designs and the final product may be earlier different from the original product. Okay, so this is a quite upward version, we can say, of a design where we required a few, or you can say moderate level knowledge related to design and some scientific skills. That is how the manufacturing process occurs, how the energy can flow. Okay, so that scientific training we needed for considering or doing a modification in an existing idea. Okay, here I have given an example of converting the mechanical watches into quartz watches. So here the new technology is adopted. Now previously, uh, mechanical watches are working on with the mechanical systems, that is a gear. Okay, and where we are using a spring so that it can be continuously working, and after the potential energy of spring reduces, or you can say uh, exhaust, then automatically watch get stopped. Now here we have converted same concept into the quartz, that is nothing but a electrical watch, where we are given a simple sail. Based on that sail, the whole mechanism works. So that to convert from mechanical watch to quartz watch, we needed a few training, or you can say knowledge related to how the electric energy we can convert into the mechanical energy. So in this way, the few technological improvement has been done in a previous design, that is called as a variant design. Similarly, any other example where the automation, or you can say any system or any process, when we go for automation, that includes in a variant design. Last one, original design. In original design, something that did not exist previously. So idea is purely new, concept is purely new, nobody has already worked on that. Okay, thus it is also called as a new design or innovative design. For making original designs, a lot of research work, knowledge and creativity are essential. So here we have uh, uh, rather than good, we required a huge knowledge of that domain, in which domain we are going for research. A company think of new design when there is a new technology available, or when there is a enough market push. Since this type of design demands maximum creativity from the part of designer, so this is called as a creative design, or you can say original design. I will give you a simple example of mobile phones. Okay, so previous in the old days, what the people are doing, they are sending a messenger to another people, so that, or telegram to the another people, so that whatever the message they have to convey from one person to another person. But as the telephone is innovative, that is an innovative thing. Okay, so that never happened before. So when telephones are come into the picture or into the market, the people are very easier, or you can say they get the benefit that I can send my message within a minute. Within a minute, I just make a call. That previous days that is called as a trunk call. Okay, now the more innovative thing is occurred, that was the wired phone, and we are now using a mobile phone. So in that is again one kind of innovation. Okay, so in a mobile phone you can move anywhere, you can carry, that is called as a portable thing. Okay, and this phone, we optimize, or for that preparation of any mobile phone, we need a huge knowledge related to electrical, electronics, computer, IT. Okay, so based on that, so the domain is now variant. So previously it is related to only for electrical, we can say, or purely mechanical, but now here all the branches are get merged, and the innovation occurs. So for getting a original idea, you must have to understood the problem. If you got a particular problem or a pain area of any customer social need, then you can do a innovative, that is a creative or original design. Now, next one, the methodology of design. It is a very essential part when we go for any design. The methodology means the action to be followed while designing, or it's referred to development of system or method for a unique situation. There are six basic actions where when we try to find a solution of any problem. So let's see what are these six basic actions. Establishing or convincing that there is a problem, or understanding that the solution is needed. So initially you have to understand the problem. Problem is a very important thing, or it is a necessary thing. If you don't have any problem, then how you can calculate the solution? Okay, so for first you have to confirm that there is a problem. Second, planning how to solve this problem. So we need to plan how to do it. By third one, by analyzing the problem, decide what is actually required from the problem solver, or we deciding the requirements. Now, if you get a problem, then we first of all find out the inputs and outputs of or outcomes, so that how we can reach that outcome, so that we need to solve it. Now generating alternate solutions to solve this, to achieve the outcome from a particular input, we need to find out the various ways to find to calculate the solutions. So just prepare those different solutions, then evaluate the alternatives for feasibility and optimality, so that we can get a optimum value, or we can say optimum design with the feasible, that is 100% working model, and presenting the acceptable solution. If it is worked properly, then we can say it is acceptable. So we will go with the simple example. In a very first step in a methodology, to prepare a list of specification which include the requirement of the product, that is called as a problem definition. And what is a basic requirement? Because whenever the requirements we consider, it could have a service life, reliability, then capacity of that product, and so on. There are various dimensions or various aspects that we have to consider. A simple example of design of scooter, that is a pure mechanical. So I will give you example of the mechanical way. For designing the scooter, we basic inputs is needed: fuel consumption, maximum speed, carrying capacity, overall dimensions, weight, and cost. So these are the basic inputs. After the careful study of these requirements of or product, the designer must have to prepare a rough sketch with the different possibilities of the mechanisms. Okay, and in that design, it should have to find out what are the possible solutions. This design in contains crank connecting rod, then converting the rotational motion of the shaft into the translatory motion. Okay, so here you have to find out the different ways how we can convert the rotary motion into the sliding motion. This mechanism involves a few what we say tightening mechanisms, that is a screw and nut bolt also. So how we can find out the basic configuration or different configuration to get the higher efficiency. Then it also contains the design of hydraulic cylinder, piston wall. Here, the basic needs is to carry the heat. So for that, we need to find out a particular material which can satisfy our needs. Also, we have to find out the manufacturing process so that it could be feasible. Otherwise, hypothetically, we can do anything, but it should not be hypothetical. The next one, we have to find out the block diagram, where we have to rearrange the components, how the motor can be supply the power, if the coupling, we are using coupling, how the motor is connected with the clutch, or how the motor shaft is connected with the clutch, then how we can connect, engage and disengage the clutches as per the operator wheel, that when we apply the clutch, automatically it disengages, and we just reduces the force, or you can say release it. It get connected with the motor shaft. So we have to design where it should be mounted. Then also we have to consider about the gear reduction point of view. What is the maximum speed is, how we can find out. Then with the optimum space, how we can design that gearbox, because the reduction ratio is normally from 1440 rpm to 5 to 10 rpm. So how we can achieve with the minimum number of stages. Then if there is another parameters for tire, then the body. So what are the basic forces are apply? What are the material? What should be the strength, rigidity, hardness, wear resistance, then fatigue strength? Where there are various factors which we have to consider in every steps. Also, we have to understood the failure modes and based on that failure modes you should have to design a particular component. Okay, so in few cases we are designing some parts purposefully for safe fail condition,